Okay, so in the last couple of videos, we talked about the object input stream and the object output stream and how it kind of relates to the byte streams we've been looking at and the character streams we've been looking at. In this lecture, I want to just very quickly talk about serialization and the concept of serialization, like the theory of serialization and serialization principally as we do it in Java. So I'll expand a little bit of the concepts that we were working with in the last two previous lectures. So here, as a quick introduction, we'll talk about serialization. We'll look at the serializable interface. We'll talk about deserialization in Java. We'll talk about why we need object serialization. We'll look at how to perform object serialization, deserialization. We already kind of seen that. We'll talk about serialization of static and transient variables and what the word transient means in this case. And then we'll talk about non-serializable data fields. We'll talk about, we'll look at some examples. We'll use an employee class as an example case. We'll look at object serialization as it relates with inheritance, so things with that is a relationship. We'll talk about object serialization with aggregation, which is what, or composition, which is a has a relationship. We'll talk about Java serialization with things like arrays or collections, so the things that we're talking about in Unit 2. We'll talk about some common uses of serialization in Java, and then we'll query a question. Can we customize the serialization process in Java? The answer, I'll cheat here and just say yes, we can. Okay, so serialization in Java is the process of writing the state of an object to a byte stream. So in other words, it is the process by which we can store or save the state of an object that's in memory in our application by converting it and encoding it into the byte stream, the same way that we've done that with characters. So once Java object state is converted into a byte stream, it can be saved or stored into anywhere, like a hard disk, a socket, a file, or we can send it over a network, right? Like the powerful idea behind streams is we don't care what the source or destination is that we can just put it in the stream and whatever is connected to it can get it on the other side. So at a later time, we may restore or retrieve those object states by using a process that's called deserialization. The class whose objects need to be serialized must be implemented with the serializable interface. So when we've seen all those collections previously, and we kept saying this implements serializable, that's what that's been meaning all this time, is that they just need membership into serializable so that it can be encoded into these object streams. And again, the serializable is inside the java.io package. And then we can, and so once you implement serializable interface, we can then pass objects to the object output stream or the object input stream, which is connected to a file and store those objects into there. If one of the objects is not serializable, then what will happen is we'll throw an exception that's named not serializable exception. So let's talk about the serializable interface. Serializable interface is a marker interface. So if you don't recall what a marker interface means, it just means that there's no methods inside of it, right? It defines no members. It doesn't have any methods. So since it has no methods, we don't have to do any additional code in our classes to implement serializable, right? You're just saying you're implementing serializable so you get that membership so that you can be encoded, but you can't be serialized without that, right? So it's super critical that any class that you want to be able to save the state of, you extend this interface or implement this interface. So the serializable interface is used to mark class objects as serializable so that they can be written to a file. If a class is serializable, then all of its subclasses are also serializable, right? So it's nice to do that from one of your root classes if you want all of your subclasses to inherit that behavior. So by default, the string class and all the wrapper classes, and if you remember, the wrapper classes are the like integer with a capital I, Boolean with a capital B, float with a capital F, D with a capital D. Those are the reference data types that represent the primitive data types. All of those implement serializable interface. So that means we can automatically, by default, write them into an object output stream. So if we want to send the state of an object over a network or file, we have to implement that serializable interface. And if the serializable interface is not implemented by a class, storing that class objects into a file will generate a not serializable exception, as I stated earlier. So the process of converting a byte stream data that's been generated through serialization to an object is called deserialization, right? And so in simpler words, it's the reverse operation of serialization. So once the state of objects is stored in a file, we can then retrieve them back. We can read those objects back from the file as we need using a object input stream. And what's great about both the serialization, deserialization process inside of Java is that's platform independent. It doesn't matter if we're on a Windows machine, a Unix machine, OS X, an Android, we can serialize an object on one platform and deserialize it on a whole nother platform or a whole another application. So to put perspective on this, think about what you're doing for homework 2. You're creating a maker toolkit so that you can produce like RPG items that's inside this application that allows you just to hold a big collection of them. Now, obviously, the next phase of that homework is to include serialization so that you can export all of that into a data file. And then if you had a video game that's going to use the same set of classes, you can import all the data that's built in your application, your maker application, so that you can actually use it inside your game. And so this way you get an idea that there's different tooling for designing the game content that then gets imported into the game itself that's discrete and different from the game. So we can take one piece of data, create it one place, and import it into another application and use it. Yeah, that's correct. But yeah, so in homework 2, you do not have to store this. In homework 3, you will upgrade the functionality of your application to serialize and deserialize. So why do we need object serialization in Java? Well, so far we have created programs where we have stored only text into files, right? And we have retrieved the same text from the files. These text files are useful when we do not want to perform any calculations on data, or if we don't need references to our objects, but suppose that we want to store structured data. So say, for instance, we have like a store employee, and that store employee might have a name and an ID number and a salary and a date of joining the job. Then we want to archive all that data together so we can reconstruct that employee inside of our application. So that's where serialization comes in. So suppose that I had an employee class that looks like this. If I wanted to prime this employee class so that we can serialize, I would import serializable, that interface from Java.io. I'd import the date class because one of the attributes of our employee is that there's a start date. Then I'm going to create my employee class, and I'm going to have to claim membership to serializable if I want to be able to do that. So we're going to implement serializable. Then I'm going to have all of my instance variables in employee. So our name, our ID, our salary, and then our join date. Then I'll have in my constructor the ability to pass these parameters in, and I will bind those to the instance variables. And so now, since employee class implements serializable, the object state can now be converted into the byte stream. It's just that simple. Okay, so why do we need object serialization in Java? Well, we looked at the first reason, to be able to go ahead and do states, right? Let's look at another reason. Suppose we want to store an array list object to perform it, we need to store all the elements in that list, and each element is an object that may contain other objects. So it'd be a tiresome process. So to make this easier, Java has provided us some built-in mechanisms to automate the process of writing the state of objects. And so this process is what's known as object serialization, which is implemented by the object output stream. So in contrast, the process of reading the state of objects is known as object deserialization. We've already mentioned this. And of course, that's implemented in the object input stream. So how do we perform object serialization, deserialization? Well, the serializable interface must be implemented by a class whose objects are to be stored in a file. So follow these step-by-steps that I have listed out here. So the first step we would connect, let's say, a object. I put txt here, but really we should put dat there, right? Because we want to be it's better to be explicit with your extensions so that they're meaningful, right? So when we serialize data, it's effectively binary data. So we don't want to give the implication that it's human readable. So we're going to have a file, let's call it object file.dat. So we would connect that to a file output stream, like just like so, example of actual code. And then we would connect that file output stream. We'd wrap that around the object output stream and then get a reference to that. And then we would do all of the reading off of that or all the writing off of those object streams using that reference. And then we can call write object methods on the object output stream to go ahead and write objects, which are all stored on that dat file. And then how do we go ahead and deserialize? Well, we would do an input stream. And again, I'm going to do the same thing here while I'm reading this. Let's say that's perfect. Oh. Okay, so we would essentially go ahead and connect to our object file.dat file that we just wrote, the file input stream, right? So now we have a file input stream that's attached to this file. And then we'll go ahead and use a reference to that to actually wrap an object output stream. And then we'd use the object output stream to call the read object method on to be able to read objects. And anytime we read an object from the object stream, it's in the state of an object. So it's in the most generic, like mother of all objects and mother of all data types that there are, reference data types as there are in Java. But then what we can do is we can cast that object into the subclass that we want it to be, and everything's a subclass to object. So in this instance, I'd subclass it into an employee and then save it as an employee reference so that I can access all of the employee methods inside of it. Okay, so just a quick little illustration to really key in on what we're talking about here. So if I have an object that's an in-memory object in my Java app, I can load it into the byte stream. So this would be an object stream that's then built on top of some other stream. And then that could connect either to a file, or it might connect to a database, or it might connect to some other in-memory application, let's say another Java application that's running, or maybe a networked application. And then now that this is archived somewhere else, right? We've written it to file, written to a database, or we stored it somewhere else in memory. Then we can actually attach a input stream either on that file or the database, or that or connect to some other application that will then load that binary data back in. But if we load this into an object stream, we can read these object streams off the byte stream back into objects. So the process of translating our objects into bytes and then storing that encoded on files, the serialization, and the act of taking the file, loading it into a byte stream, and then putting an object stream on top of that so we can read them back in as in-memory object instances is deserialization. Yeah, so the nice thing about this, so I have a question. So this can be used, for example, to save someone's food order. Yeah, so what's awesome about this process that we're talking about is before, when we're looking at input and output streams, we're talking about being able to like archive text data from your application. And so that's human readable, right? And so we were also talking about byte data. So we're talking about being able to even like store primitive data types onto our data, onto our data files, onto files. And so that was kind of limited, but useful. This extends that concept. And so if we created, like, say, for instance, a food order, we can save that food order to a file. We can quit our application. We can relaunch our application. And normally, we don't have data persistence. Normally, in our Java applications, the minute they shut down, you lose whatever data was populated while your application was running. Serialization allows us to take all those in-memory objects and store them in file in a way that we can load them back into memory and bring those objects back into existence. So it allows us to have data persistence between when our application is shut off and then comes back on again. So if we want to recall, let's say, that food order, if we save it to a file using an object output stream, we can then load an object input stream, load it into there, and then read it back into our application, and then access it again, access it in memory again. So to compare this like with the homework, if we wanted to create like a big inventory of RPG items, like a collection of swords and a collection of shields. And you spend an hour creating all these shields and swords and spears and daggers and wands and maces and whatnot, axes. You could then store the state of all those instantiated objects into a file, and then you could shut the application down. And then normally when you would relaunch the application, you would lose all that data. But if you serialize it first, you can have a mechanism where you can load it back in from file and recall all those original states so you have access to them again. Now, what's cool is you can make one application that allows you to design your equipment, right? And then that's all that application does. It's just used to build equipment for the game. But then you can archive it, right? You can serialize it out. And then inside the actual game, you can create an object input stream that reads in that data, and that imports all the weapons you built in another application. So it's not just about being able to save data and reload data in the same application. It allows you to save data from one application. If you want, reload it in a whole nother application. So it's super powerful. It allows us to take data out of our application and put it back in our application or some other application. Does that answer your question, by the way? Okay. Let's talk a little bit about serialization of static and transient variables. Any static and transient variables declared inside a class cannot be serialized because we're serializing objects. And remember that anything that's defined as static is part of the class itself, not part of the object. Now, static variables are already accessible from the class level anyway, so there's not any real point to serialize that, right? The idea behind serializing objects is because each object can have its own discrete individual set of values. So if there's a static variable, well, we can always just recall that. We can always just recall that from the class. Now, if you have a mutable static variable and you do want to save that, you can always just save that as like a primitive data type if you want, and then create your parser application that would then reload that back into the class definition. But you can't use object streams to save static variables because, again, that's at the class level, not the object level. Transient is a keyword we haven't seen because it didn't have any relevance until we got to serialization. So transient's the keyword we use if we don't want a particular variable to be serialized. See, so if you don't want to serialize a data member, just label it as transient and it will prevent that serialization. So talking about non-serializable data fields, suppose that we have a class that implements serializable interface and also contains the non-serializable object data fields. Can non-serializable data fields then be serialized if a class implements serializable? And the answer is no, right? So to enable the object not to be serialized, right? If it isn't serializable, then we have to declare those data fields that haven't been serialized, the ones we have a relationship to. And if we want that object that we're implementing to be serializable, then we would have to define those as transient. And then the JVM will ignore anything that's has that transient keyword when we're writing the object to the byte stream. So imagine if we had this. So talking more about non-serializable data fields. So imagine if we had a public class A that implements serializable. So here, obviously, the intent is we want to serialize, we want the capability of serializing class A into an object output stream. Well, we have an integer, so we know an integer can go ahead and be encoded. A float can be encoded as data fields with has a relationship. Both of these also implement serializable. And let's say we have B here, and let's look at this. B does not implement serializable. So we would not be able to serialize A because one of A's dependencies is on B, and B is not serializable, which means A is not serializable because it has a dependency that isn't serializable. However, we can bypass that. And if we label B as being transient, now A can be serialized because the thing that isn't serializable, we're going to tell the JVM to ignore. So when an object of class A is serialized, only variable X will be serialized, right? Yeah, and Y is not serialized because it's static. We already said static variables can't, because it's property of the class, not property of the instance or the object. And then B will not be serialized because since it's marked transient, it'll be ignored. And otherwise, if we didn't do this, we would get a not serializable exception occur, because we tried to serialize A, and then it tries to serialize all of A's instance variables, and then it wouldn't be able to do that one. Anyway, let's take a look, quick example code where we try to serialize objects of the employee class. And what we'll do is we'll use the write object method of the object output stream class to provide the functionality to serialize the states of object we want to store, and we're going to store that in an employee file.dat file, a data file. So this is our source code for that, and we're gonna have a class file. And I'll actually just look at this class file here, because I don't need to necessarily we're not going to run it, right? Because we're going to build some like tester class around it. So our employee class is going to implement serializable. It's going to implement date, right? We're going to create a class definition, employee implement serializable. We're going to have all of our instance variables. So a string that represents a name, an integer that represents the ID, a double that represents the salary, and a date instance that represents our join date. Then we're going to create a constructor where we can pass in all those parameters and bind those to the instance variables. And we'll create a toString method too, just so we can print out the state of our employee. So then when we go to our employee, our serialized employee class, and actually, why don't we hop into there over here? We'll take a look at it. So let's go here, serialize employee. So inside of serialized employee, I'm going to go ahead and import a file output stream, and I'm going to import a object output stream, right? Because I need a one stream to wrap around the other stream. I need a file stream or some other type of output stream to wrap around the object output stream. I'm also going to import my IO exception and my date class, so I can actually create an instance of employee. Going to create a class just to test this out. We'll call it serialized employee. Going to create a main method that just throws that IO exception. Going to create a new instance of employee with a name, Ted, with ID number 12345, a salary of $300, not very high, and a today's date, new date. Here we're going to build a file output stream that's going to go ahead and save to this employee file.dat. And we're going to attach to that .dat file, and then we're just going to, and since we're writing that, doesn't necessarily have to exist. So if it exists, I'll just delete it right now. So let's delete that. There it is. Okay, let's delete that. Yeah, go ahead, do that refactor. Perfect. Then what I'm going to do is I'm going to take this file output stream. I'm going to wrap it. I'm going to wrap this object output stream around that file output stream. And then I'm going to use this object output stream to actually write my in-memory data, right? My instance of employee, write that object to that output stream. And then I'm going to flush that stream and I'm going to close it. And then if all that happens successfully without throwing an exception, right, I'll just do serialization is done successfully. Let's go ahead and run that. Serialization is done successfully. And there we can see we have an employee file.dat. And just to prove this isn't human readable, if I open it, you'll see it's just nothing but garbage, right? There's a file loaded, but it's not the encoding. There's no encoding. So it'll try to map it to characters, but nothing meaningful. Excellent. And so in the next example, why don't we build a program where we can retrieve back that data, right? Using the employee file.dat and then the object input streams. So again, this is going to be our source code, super simple, but let me go ahead and open it in here, deserialize employee. So here I'm going to go ahead and import my file input stream. I'm going to import my object input stream. I'm going to import my IO exceptions. I'm going to create a new class, deserialize employee. I'm going to have a main method here. This main method is going to throw the IO exception, then also a class not found exception, since we're trying to open a class for reading, a file for reading purposes. So I'm going to create a new file input stream using that file path with the employee file.dat, and I'm going to save that into memory. Then I'm going to use that file input stream to build an object input stream around it. and then I'm going to read that object, right, as a data type object into memory, and then I'm going to cast that object into an employee, and then I'm going to actually print the state of that employee. So if I go ahead and run this, you can see I'm going to be able to reload that employee class back into memory, and I'll be able to redisplay all of its data, right? The name, Ted, ID 12345, the salary $300, and hired at this date. Okay, so let's talk a little bit about some of the more how object serialization plays with some of these kind of polymorphic behaviors or some of these object-oriented behaviors that we have in Java. So let's talk about object serialization with inheritance, which is that is a relationship. If a class implements serializable interface, all its subclasses will also be serializable. So let's look at the following code. Suppose that we have here a serializable, so we import serializable, and then we're going to create a class person that implements serializable, and person has an ID and a name and just a constructor. Then suppose we have a student class that extends person, and then for our student, we also have a course and a fee, and then we have this constructor that takes in all the stuff that person needs and then all the stuff that student needs. So it'd be ID and name and course and fee. And then we would go ahead and on the first line of the student's constructor, invoke the parent classes, the super classes constructor, because it requires 2 parameters. And then I can go ahead and set my own instance variables here. Well, since student extends person, and since person is serializable, then student would also be serializable. So that's how that relationship is going to work, just like it works with other interfaces, right? Let's talk about object serialization and aggregation or composition. So anything that has a relationship. So if a class has a reference to another class, all the references must also be serializable. So this is a little bit more complicated, right? This is a little bit more prone to failure. So otherwise, the serialization process will not be done. In such a case, at runtime, an exception named not serializable exception will be thrown. So just looking at this, suppose that we have this class here, address, that's not serializable, right? It has a string, that's the address line, a string for a city, a string for a state. We have a constructor that allows us to create an address. Now, if we have here a resident, public class resident that implements serializable, that has a string name and address, that's has a relationship, and that address is not serializable. So if I tried to do it this way, I'd actually get that exception, right? Since address is not serializable, we cannot serialize the instance of resident unless we mark this as transient. So all objects within an object must also be serializable for an object to be serializable. Okay, let's talk about Java serialization with an array or collection. An array or collection is serializable if all its elements are also serializable. So if an element is not serializable, this serialization process will be failed. So it's the same idea there. Like you can do, keep in mind when we're looking at everything in collections, all of those collections implemented serializable, but the underlying elements also have to be serializable, the things that are contained within the collections. Okay, let's look at another example where we actually go ahead and serialize and deserialize an array. So here we'll make a sample program where we will store an array of, let's say, 5 integer values and an array of 4 strings. And what we'll do is we'll write it to a file and then read them back from the file and display them on our console. So we're going to import lots of things to do this, and we're going to have some source code, and it's going to be called serialized array. Let's take a look at that. So let's go to serialize array. And so here our imports, we're going to go ahead and let me move some of this around so it's a little bit more readable. Perfect. And I'm going to put the exceptions at the bottom. Okay, so here I'm going to import my underlining input and output stream. So I'm going to attach to a file. So I'm going to use file input stream and file output stream. Then I'm also going to import my object input stream and output stream that are going to wrap around my file input stream and output stream. And of course, these are the exceptions that might occur. So I need to import those, an IO exception and a file not found exception. So I'm going to create a quick class here, serialized array. I'm going to create a main method that's going to throw all those exceptions that might happen. So file not found, IO exception, and class not found exception. Class not found exception is an exception that might occur if we try to read or write a class that that isn't found to our stream. IO exception is for all IO stuff we do, and file not found, so the file path does not exist. Here, we're going to create a array of numbers, puts 5 numbers in there, 10, 20, 30, 40, minus 50. Here, we'll create an array of strings. So John, Ted, Deep, and Kim. Here, we're going to create an output stream for our file. Our file we'll call arrayfile.dat. And so we're just going to do this in one line. So here I'm building a new file output stream on this file path here, arrayfile.dat. And around that, I'm going to then pass as my parameter to generate a object output stream, right? So I'm wrapping one around the other, and I'm going to hold a reference of just the object output stream because that's all I really care about. That's where all my calls are going to. Now we're going to use that right object method we've been seeing, right, to be able to pass a number in, to be able to pass those strings in. Now that's numbers, that's my array, so I can pass that entire array in. And since an array is an object, and since it implements serializable, I can serialize the entire array, right, to my file. Same thing here. So again, when we're talking about your maker tools and making your application potentially serializable, you can save the entire collection all at once to a file using this methodology, and it's relatively simple. So this would store all of the integers in the array, the entire contents of the array object, to our object output stream, and this will store the entire array of strings to our object output field. And once we're done, we'll flush and we'll close. Then what we want to do is to prove that we've successfully written them. Let's go ahead and open that back up, that array file. So what I'm going to do is I'm going to create a file input stream, right? A new file input stream. I'm going to pass in that path of arrayfile.dat, and then the resulting object I get back from that file input stream object, I'm then going to pass and wrap an object input stream around, so I can get access to all the methods to actually read as an output stream, as an object stream. And then I'm going to save that into a variable that's just called OIS, object input stream. Then I'm going to read that. Then this is what I'm going to do. I'm going to read the object, the first object that was written into from the file, from the arrayfile.dat. I'm going to read that, and I'm going to cast it into an integer array. And I'm going to save that into a local variable that is an integer array that's called new numbers. And then I'm going to do the same thing. I'm going to read the next object from that arrayfile.dat, and I'm going to cast that into a string array. And I'm going to save that into a new local variable of a string array. Then I'm going to close my object input stream. Then what I'm going to do is I'm going to iterate over each value. So I'm going to index, right, from 0 to the length of my array. And so it knows how big the array is from this object, right? Java already knows that. And so it'll then print out the contents. It'll index into the array and print out each of the elements of the array. And when it's done, it'll make a new line. In fact, let me hit run here so we can actually see the output. And so this first for loop will iterate 10, 20, 30, 40, 50. Then we're going to do the same thing. We're going to have an index value of 0. We'll go from 0 until on our new strings, we hit the length. And then we'll do a system.out.print where we index into the array using that index value, that looping value, and we just print out each of those values. So John, Ted, Deep, and Kim. So you can see how easy it is just to go ahead and serialize our array data as well. So the question is, what are some common uses of serialization in Java? Well, the advantage of using serialization in the serialization process in Java, well, it allows our objects to be sent over a network, or it allows our objects to be saved to a hard disk or file, or objects can be serialized to be preserved or sent to another application. So like clearly there's a lot of value on serialization, and it's not that difficult to do. So can we customize the serialization process? So right now, because serializable doesn't have any methods, it just kind of happens, right? And so we can either label some fields transient if we need to. We know that we can go ahead and capture all the other instance variables, but what if we would just want some of them? Or what if we want some control over what gets serialized? Well, we can do that, but we can't do that just with serializable. There is the ability to implement what's called the externalization interface, which is actually externalizable. And so this interface contains two methods, read external and write external. And if we implement those two methods and write logic, we can control the serialization process on a per class basis. And so we will look at that less presentation, and then that will do us with serialization. So is there any questions in terms of serialization? Any questions in terms of what we covered in this particular presentation? Okay, well, so next lecture, we will go ahead and finish off with, because I'm out of time this lecture, I only have 2 minutes left, not enough time to go through the last slide deck. So yeah, I'll be able to, meet with you just to go over homework 2 after lecture. That's definitely doable. And like I said, I'm going to extend the due date on homework 2 as well to be to probably the 28th. But it's going to have, I'm also going to put the homework 3 document, and homework 2 is, it was always intended that homework 2 gets upgraded with the data that we're learning in the Unit 3, the IO management component, where instead of just being able to create items inside your application, you'll then have the option to do one of two actions. The first will be to batch load from a text file a lot of new instances. So you can have someone who's like not a developer, who you get to define the parsing logic, but you can have like the name of an item, the description of item, like the attack value, the defense value, whatever. And you can just have like lines of it that you can then import into your application. And then the second thing you'll have to have in your application is the ability to serialize the data. So you can take it out of your application and then import it into a game that could be built around it. And that'll have the same due date. So you can start upgrade. And then when you don't have to do audits independently, what we'll do is we'll just do an audit that counts as homework 2 and homework 3, probably, sometime next week. Excellent. Does anyone have any other questions? So the second test is on Moodle, and I do have the due date set on this Friday. So you should have all week to go ahead and work on that test. And I want to say it's the exact same number of questions as the first test. And then it's my intention to spend this week grading the first test so that I can get all your grades onto Moodle for you. And if I'm missing any homework grades from anyone who hasn't done audits yet, I'll probably reach out to you sometime this week, just to make sure everyone's on board. Okay, excellent. If there's no other question, I will go ahead and end today's lecture. Everyone have a great day. I'll see everyone tomorrow.